You're tuned in to the Dish TV, the talk show from SRI International that highlights our people, products, and technology portfolio. This series will focus on the Quantum Economic Development Consortium, or QEDC, supported by the National Institute of Standards and Technology and managed by SRI International. The QEDC is a consortium of stakeholders that aims to enable and grow the U.S. quantum industry. I'm Renita Malhotra Hora, Head of Marketing and Communications. In this episode, my guest is Christopher Savoy, CEO and founder of Zapata Computing, which specializes in workflow management for quantum hardware and software. I asked Christopher about Zapata's origins, its role in the quantum supply chain, and why it became a member of the QEDC.
Quantum, we believe, promises the ability to solve problems that are really beyond the reach of current computers, classical computers, as we call them. We founded Zapata to accelerate the quantum technology revolution, which is, we believe, becoming the second major information processing revolution in human history. So it's a big deal.
Anything you can tell us about Zapata Computing, when it was founded, and why?
Yeah, we actually were founded as a spin-out of the Ilan Asparagusic. Ilan is my co-founder and chief scientific officer of Zapata Computing at Harvard. We spun out of Harvard University in late 2017 to commercialize some of the early work in quantum computing algorithms that was done in the Asparagusic lab.
It sounds like quantum computing specifically is the technology that your company is developing. Can you tell us a little bit more about your specific role in the quantum supply chain?
We see ourselves as really the enterprise software company that helps customers get the most value from the current state of quantum devices. Our unified quantum operating environment, Orquestra, is currently the quantum computing industry's only fully integrated quantum workflow management system. It allows users to build workflows from any quantum library, such as Cirq, Qiskit, Pikewill, or classical libraries like TensorFlow, QuantLib, QBSolve, and then run those workflows across a full range of quantum and classical backends, and finally analyze those results. This requires us to be closely partnered with all the hardware companies, and to know what the most effective software libraries are so that we can integrate them. One customer that we have describes Zapata as, the capability that we don't yet have in our company. You build a platform for us to be able to use the hardware is what they've told us. And Orquestra really delivers Zapata's research and IP as well, in the form of libraries, core quantum algorithms, so that others, in Fortune 100 companies and government agencies can leverage the work of our 25 plus NISQ algorithm scientists who work at our company.
Can you explain to us in a little bit more detail about Orquestra? It's a workflow management system, the first of its kind. What does that mean, and why is it necessary for us to know about or have?
It's a workflow management platform, and actually, it was born out of necessity. It began actually for us as an internal tool, and it was designed really to accelerate our own scientists' work by providing a framework to collaborate, and really to scale our own developments to an arbitrary large size for some of the large problems that we've described. After seeing our own scientists produce results in weeks that would have taken previously, using our academic tools before we got our hands on this, closer to a year even in some cases, we realized that this tool really could help accelerate the growth of the industry outside of Zapata. And that's where we put our efforts to really commercializing this and making this available commercially to the wider community. So we aspire to make Orquestra the ultimate, quantum assembly line, if you will. And today we're at the beginnings of this quantum revolution. But this is a big part of that is, using interchangeable quantum parts that we offer in these workflows. So, I want to do this and I want to do this, and these are pre-existing. How do I combine them together to make a greater product whole?
How do you see these workflows changing or evolving over the next, say, year, 5 years, along with the development of the quantum industry?
Well, I think that there really is an interplay between software and hardware. It's naive to think that okay, the software people need to wait until the hardware exists and then you develop the software and it runs. That's really not how the computing industry even developed. It's very much an iterative, collaborative process. With our partners, we're able to our hardware partners. We work hand in hand in a lot of cases on use cases, and what we learn on the software helps drive hardware requirements. So what we learn from the use cases and what we need to do will help drive, what kind of gates we need to use in a quantum computing device, and vice versa. Some of what we learn about the noise models and the characterization of these new devices informs us in how we write our software. So really, we believe that an industry as a whole working together we will be able to accelerate things. And that's why, the pre-competitive environment of QEDC is so important, because it allows us, an environment, a pre-competitive environment in which we can interact with other companies in this space who share some of the same goals in really iterating and making that virtuous cycle go around.
What might you say are the biggest barriers to commercializing some of these technologies?
I'd say that talent and tools are currently the biggest bottlenecks. They're really slowing the growth of the quantum technology industry as a whole, not just quantum computing, but in other areas. The community is not producing enough researchers with the expertise in quantum algorithms to meet the demand. And researchers need to be sophisticated coders as well as learned in quantum computing, which is a big ask to have both of those. And they have to know application areas. So the industry has begun providing some new tools to make creating and running quantum algorithms easier. But in reality, the systems on both the hardware and the software sides really aren't interchangeable either. So coders, quantum scientists, they're forced to learn and glue together really an ever increasing set of languages and libraries. So solving this problem is really Zapata's main focus right now, and what we hope to contribute to that. To provide an analogy, I guess, quantum computing software looks like, the pre-industrial revolution manufacturing industry. Manufactured goods were produced by individual experts. In some cases, they brought together, right at the very end to make the final product. But manufacturing took a huge leap with this concept of interchangeable parts. And again, with the development of the assembly line. In each case, the burden of the expert was reduced while simultaneously enabling a better end product at the end of the day. So in the classical computing industry, a similar leap was taken in the development of operating systems. And we really don't have that kind of integrated system right now, the equivalent of what we've had in manufacturing or classical computers happening in quantum.
Talking about the QEDC, which has relatively recently, come together, bringing all of the different stakeholders in the industry to collaborate and work with each other, develop their network and their sales systems and so forth. Is the organization critical in helping Zapata Computing specifically solve some of these problems? Is that why you became a member?
Especially as an emerging company that's not a Fortune 100 company ourselves. There's strength in numbers, so it'd be one thing for us to try to solve this as an individual company. Even large companies, one large company, one large Fortune 100 company that's making quantum computers, by itself would not be able to engage a lot of the big machinery we need to turn around to make this all work. We're talking about interacting with governments and getting this solved on a policy level, and that's really hard for a small company or even a large company by itself to really affect change. And so, by working with our peers in the industry, with quantum computing, quantum sensing, quantum communications across this area, we can really, and we share a lot of the same issues. We can really work together to have industrial solutions for this, but also interact with our peers in government, the government members of QEDC, and some of the national institutes to try and alleviate some of these systemic problems that really hamper our ability to grow this industry.
your involvement in QEDC, it goes beyond membership, as I understand. You committed to being a chair. Can you tell us why?
Yeah, I'm on the steering committee actually. Yeah, I'm a member of that, and I guess I was nominated was is the short answer, and then we had a vote from our peers to form the steering committee from the quantum industry. I was interested to contribute what I had to bring to the table. From my technical background, but also on the side, I happen to be a lawyer as well. So, and there are some issues here that we have to deal with that are not just technology. They have policy implications, they have legal implications, societal implications, and I think that I had a chance and an opportunity to bring some of that conversation into this, so that it's not just the technical scientists leading the discussion, because at the end of the day, like I said previously, we have to move a lot of the levers of government and policymaking and these kind of things to make sure that the U.S. industry and the general industry in quantum computing is competitive and has the right policies in place. And so I thought that I would be able to share some of that background that I have to really add value to the committee.